A nuclear power plant is basically a giant kettle, but instead of using fire, it uses splitting atoms to boil water. Here's how a nuclear power plant works. At the heart of it all is the reactor core packed with fuel rods filled with uranium-235. When a neutron hits a uranium atom, the nucleus splits, releasing loads of thermal energy. This process is called nuclear fission. But here's the crucial part. That split of the nucleus releases more neutrons, which bombard more uranium atoms, creating a chain reaction of nuclear fission. But there is a problem. These newly released neutrons are fast, and fast neutrons are not so great for fission. That's where the moderator comes in. It slows down the neutrons just enough so uranium-235 can absorb them more easily, keeping the reaction going just right. But what if these chain reactions get too intense? This is why we need control rods, often made of boron. These rods absorb neutrons, acting like an off switch for the nuclear reactions. If things get too heated, we lower the control rods into the reactor, reducing or even stopping the chain reaction. Now, all that heat from fission boils water, creating high pressure steam. The steam spins a giant turbine, which powers a generator, and that's when the nuclear power plant has successfully generated electricity. But what happens to all that leftover heat? A coolant, usually made from water or liquid sodium, circulates through the reactor to carry away excess heat and prevent overheating or even nuclear meltdown. And because radiation is dangerous, the entire reactor is surrounded by thick shielding made from concrete and lead, keeping the radiation safely contained. Nuclear power is crazy efficient, and it doesn't burn fossil fuel, so there's no carbon dioxide emissions. But here's the catch, and that's also why many are fearful of nuclear power: radioactive waste. And not all waste are treated equally. We categorize them into three levels. The worst of the worst: spent fuel rods straight from the reactor. They are insanely radioactive and super high. First, they need to sit in cooling pools for years. Then, depending on the country, they're either reprocessed or sealed in massive casks for long-term storage. The long-term plan is to bury them deep underground for thousands of years, far away from anything that matters, like humans. Then there's the stuff that's still risky, too radioactive for the trash, but not extremely dangerous. Things like reactor parts and used filters. We mix it with concrete, seal it in drums, then store it underground. Just not as deep as spent uranium rods. And finally, there's the everyday waste. Gloves, tools, protective gear, stuff that's been near radiation, but not too bad. This gets packed, compact, and stored in shallow disposable sites. Some of it even decays fast enough to be treated like regular trash after a few years. So nuclear power is one of the cleanest energy sources we have, but waste management is the key. So what do you think? Is nuclear power a game changer for clean energy, or is the risk too high?